Good morning, everybody. Today we are going to see how to simplify and organize data using frequency distribution technique. It is a method of descriptive statistics which comes under the course Foundation of Data Science. First, let's see what is frequency distribution. After collecting data, the first task for a researcher is to organize and simplify the data so that it is possible to get a general overview of the results. This is the goal of descriptive statistical techniques. One method for simplifying and organizing data is to construct the frequency distribution table. A frequency distribution is nothing but an organized tabulation showing exactly how many individuals are located in each category on the scale of measurement. A frequency distribution presents an organized picture of the entire set of scores, and it shows where each individual is located relative to others in the distribution. So a frequency distribution table consists of at least two columns, one listing categories on the scale of measurement and another for frequency. In the X column, values are listed from the highest to lowest without skipping any. For the frequency column, tallies are determined for each value. These tallies are the frequencies for each X value. The sum of the frequencies should equal n. A third column can be used for proportion for each category, and the fourth column can display the percentage of the distribution corresponding to each X value. Now let's see what is regular frequency distribution. When a frequency distribution table lists all of the individual categories, it is called regular frequency distribution. Now, we can construct the frequency distribution table for grouped frequency values as well. Sometimes, however, a set of scores covers a wide range of values. In these situations, a list of all the X values would be quite long, too long to be a simple presentation of the data. To remedy this situation, a grouped frequency distribution table is used. And in a grouped distribution table, the X column lists group of scores called class intervals rather than individual values. These intervals all have the same width, usually a simple number such as 2, 5, 10, and so on. Each interval begins with a value that is a multiple of the interval width. The interval width is selected so that the table will have approximately 10 intervals. And we can draw graphs from this frequency distribution values as well. So in frequency distribution graph, the score categories are listed on x-axis and the frequencies are listed on the y-axis. And we can draw histograms for this as well. In a histogram, a bar is centered above each score so that the height of the bar corresponds to the frequency and the width extends to the real limits so that adjacent bars touch. And we can draw polygons for this frequency distribution values. In a polygon, a dot is centered above each score so that the height of the dot corresponds to the frequency. And we can draw stem and leaf displays for this as well. A stem and leaf display provides a very efficient method for obtaining and displaying a frequency distribution. Each score is divided into a stem consists of the first digit or digits, and a leaf consists of the final digit. And we can construct a stem and leaf like display for our frequency distribution. In our further video, we will see the example for how to construct the frequency distribution table as well as how to draw the histogram, frequency polygon as well as stem and leaf display. So consider this example. This example shows the minutes spent by a person on a phone. And these are our observation. we have got these many values, and here we are going to create a frequency distribution table with the 5 classes, and before that we have to consider the minimum as well as maximum value from this observation. From when you look into the observation, you can find that the minimum value here is 67 and the maximum value is 125. Kindly make note of that before proceeding. And now let's see the steps to construct a frequency distribution table. First, we have to choose the number of classes. It should be approximately between 5 and 15. Now for this problem, we are considering 5. And we have to calculate the class width. For that, the formula is you have to consider the maximum value minus minimum value, and you have to divide that by the number of classes. Here, as the maximum value is 125 and the minimum value is 67, so the value is 125 minus 67 by 5. We'll be getting the answer as 11.6, and we are rounding it up to the next number, that is 12. And next thing is we have to determine the class limits. So the lower class limit is the lower data value, and we have to add this class limit with the class width for the further values. And we have to mark a tally after writing all the observations in the table, class values in the table. What we have to do is we have to make a tally for each and every observation. Let's see the example. In our example, the minimum value is 67, the maximum value is 125, and the number of classes is 5, and the class width is 12. So the class limit is 67 to 78 is one interval, 79 to 90 is another interval, 91 to 102 is another interval, 103 to 114 is another interval, 115 to 126 is another interval. So for that we have marked the tally as well. For each and every observation we have to mark the tally here. And after doing the tally, we have to count up the number of lines in the tally, and then while counting up we will be getting the frequency values. So this is our basic frequency distribution table. And how we can draw the frequency histogram is, for each and every class we have got the frequency values, so we have to mark the boundaries for the histogram bar. So 0.5 before the first class lower limit, and 0.5 after the first class upper limit. After making the boundaries, we have to mark the bar with the frequency values, and we have to plot it in the graph. And for frequency polygon, we have to consider the midpoint of each and every bar, and finally we have to map it with the straight line, so that we'll be getting a frequency polygon. And other informations which we get from here is we can find the midpoint for each and every interval. Then we can find the relative frequency. The formula is class frequency divided by total number of frequency. And next one is cumulative frequency. We have to add up with the lower values, that is number of values in that class are in lower, we can find using cumulative frequency. And for relative frequency, we can draw the histogram as well. And for stem and leaf plot, we have to consider the number of the last digits for leaf and the remaining digits for stem. So here we are considering the first 2 digits for stem and the last digit for leaf. If the number has only 2 digits, then the first digit will come under stem and the second digit will come under leaf. So our stem here is 6, 7, 8, 9, 10, 11, 12, and the leaf is, how we have to mark the leaf is, first we have to consider the first observation, it is 102. So here the stem is 10 and the leaf is 2. So we have to mark 2 in the stem, 10. Likewise, For 124, the stem is 12, and for the stem 12 we have to mark the leaf as 4. For 108, the stem is 10 and the leaf is 8. And for 86, the stem is 8 and the leaf is 6. And for 103, the stem is 10, the leaf is 3. And for 82, the stem is 8 and the leaf is 2. So by this, by following this procedure, we can draw the stem and leaf display for the complex values as well. So that's all about the uh, how we can construct the frequency distribution table and uh, plotting the graph as well. So we will meet in other video. Thank you.